So anyway, the topics that we are doing now is actually related to one another, which are now the uses of your derivatives. Okay, so it's not actually that different. Okay, so that is it for a few announcements and some reminders. And for our lesson today, we are going to continue on with our discussions from last meeting on how to apply your derivatives in calculating or in maximizing or minimizing components of a certain calculation. Okay. However, we cannot go directly to that, your minimization or maximization, since we are still trying to learn the basics of it. Okay. And the first topic that we discussed last meeting was your higher order derivatives. Okay. And it sounds complicated, higher order derivatives, but basically it's telling you to just take the derivative of a certain function multiple times, right? That's in short, in summary of the topic last meeting. Just taking the derivatives multiple times. Okay. So for today, we continue. We move on. Okay. So let's start. So after knowing how to take derivatives of certain functions multiple number of times, what we need to learn now is the type of functions, okay, that where we are going to use maximization and minimization. There are two types of functions that we are interested in, and that is now your increasing function and decreasing function. Okay, when you say increasing function or decreasing function, this is now the value of a certain function or the behavior of the value of a certain function as the value in x increases. Okay, so what do I mean by that? So let's say now that we have a certain function f of x is equal to x plus 1. Okay, f of x is equal to x plus 1. That's a very easy or basic function. Basically, if we are going to graph this, we will have something like uh, yeah, something like this, right? Okay, so f of x is equal to x plus 1. Now, the thing here is, depending on the behavior of the function or the values of x that we are going to place here, okay, an increasing function is defined as okay. So to have an increasing function, okay, it is now defined as the value of the function increases as x increases. Okay, what do we mean by that? If we input a value x1 over here, it will have a certain value in y. Okay, this is now its equivalent value of the function. Okay, so this contains now the value of the function. Correct? If we input a value in x1, let's say x is equal to 1, the value of function is equal to 2. So there, correct? So what is now the behavior of the function when we increase x? Okay? When we increase x2 is up here, what is now the value of the function? The value of the function obviously is going to, based on this graph, the value of the function is also going to increase, naik, right? It goes up. So as x increases, the value of the function also increases. For all values of x, as long as we increase it, what's the behavior of the graph or of the function based on that? Even if from x2, if we increase it again to x3, what do you think? Will it change? Will the value decrease? No, right? The value is still increasing. So that's the behavior of this graph. So take note, an increasing function is when the value of the function is increasing as long as the x, okay, the position of x is increased, then we call it as increasing function. Okay. Now, this is not the okay? So what else can be an increasing function? If the graph, for example, is like a logarithmic graph, okay? Logarithmic, oh, remember this one? When we were in SMP?
Yes,
Okay, this
teacher.
graph, logarithm, this is now y equal to a raised to x, right? This one. So when the value of x is here, x1, our value in the y is just up to here. Okay? If I increase x, I will put x2 down here. x2, the value of x increased, that's too far. Let's put it closer so that I will have that one. So x2, the value of the function also increase up here. Okay, so ini naik. Okay, so this one, in this setup, this is still called your increasing function. Clear? Other possible graphs that are going to give you an increasing function. Remember your containers, the exercise on containers and water, filling containers. Okay, so remember, we can also have something like this. This one is still going to give us an increasing function. X1 is here. And then if we increase x, x2 also increases. So like, okay. So all of these are now examples of increasing functions. Clear? And these are now
Clear.
increasing functions for all possible values of x. Clear? Now, the opposite of your increasing function is now called your decreasing function. For decreasing function, it is now, I'm going to copy this because I'm a bit lazy today. Okay, place it there. So instead of an increasing function, we also have something called like a decreasing function. Okay. What's a decreasing function?
The value of the function will
Decreasing function.
decrease.
Now the value of the function will decrease. Very good. The value of the function is now going to decrease. As x increases, As you move x farther away, what happens is instead of the value of the function going up, the value of the function now is going to go down. So that's now a decreasing function. Okay, so how does the graph look like for this one? So if we start with the linear graph, we will have something like this. Okay, why? Because look, value in y is high, correct? But if I will now put the increase, I will increase the x value, put x2, that's higher than the x1, what will happen? The value of y decreases. It goes down. Okay? The value goes down. So we have a decrease. Clear? So when we have something like this is now a decreasing function. Okay? Clear? Other examples of decreasing functions, we can also have the opposites of all of this. Okay, opposite of this one. Negative value in the logarithm. Negative a in logarithm or exponential. This is graph of x raised to n of negative a. Okay, like this. So same idea. When x1 is here, x1, we now value of the function in x, that's x2, the equivalent value of the function, okay, still went down to 1. Okay, so are we clear on this?
Sure, the graph besides the decreasing function, is that an example of increasing or decreasing?
Which one?
The graph in the middle, however, it's on the bottom.
One?
Which one? Sure, I cannot see here. Yeah, that one.
What do you think? X1 is here. X1 around 1. Value there is 1. X2 is around, let's say, 4 or 5. What is this? Increasing or
Will
decreasing?
increase, yeah. So it does not matter whether or not the rate will slow down, teacher.
Doesn't matter.
As long as it's increased.
As long as it will increase.
Okay, thank you, teacher.
Even if it is very small already, but as long as not flat, it is still increasing. Line, there's no change, right? So we cannot say that that is increasing or that is decreasing. It's constant. Okay? Clear? Okay, so at this point, since it's already clear how an increasing function or a decreasing function looks like, there are actually, you can actually, you cannot generalize. It will be constantly increasing or constantly decreasing. There are functions that are constant. There are functions that you can consider that it will never change. It will always be decreasing or it will always be increasing. But there are also functions that a portion of it is increasing and a portion of it is decreasing. Okay? What do we mean by that? Well, here, when we have a linear function, this one, I can classify as a uniform. It's just either increasing or either decreasing. Understand? There's no part of it that can become decreasing and then part of it increasing. No. So this is a uniform function. However, if we compare it to a parabola, if we compare it to a parabola, there, is this a uniform function wherein we can sing function? Mm. Can we say that this is just, oh teacher, this is a 100% increasing function? Can I say it like that? Can I describe it like that?
No.
Yes or no? No. Okay, we cannot. Why? Because portion of it, let's say from here to here, here to here, what do you think is this one? From here, what?
That is
Increasing, decreasing?
decreasing. Decreasing.
Okay, so this part from x1 to x2, okay, x1 to x2, we can say that this is now decreasing, okay? But if I am now going to compare from x2 to x3, x2 to x3 over here, this is now going to become
Increasing.
increasing. As the value of x decrease, but from comes increasing, okay? So this is not a uniform graph. It has changes in the middle. So if you have changes in the graph like this, we say that this is now increasing or decreasing, increasing or decreasing function on an interval. Okay, so we need to consider the interval where we are going to be looking at that certain function. You understand? Clear? This one clear? Yes or no? Okay, so increasing and decreasing function on an interval. There are many functions. I think most or majority of the functions fall under this category. It's either an increasing or decreasing function on an interval. Okay, so this is now my question to all of you. How about you define a function? Will it be a uniform one or will it be mixed? Hmm. Anyone? Cubic?
I
The
think
answer
cubic
to
would
that
be
is
mixed.
okay. There, my answer there is you are partially correct. It can be increasing or decreasing function at an interval. Why? Because I can get a cubic function like this, correct? So this one, depending on the function, we will now be having a part of it that is now increasing, some part of it decreasing, and then some part of it increasing again. But take note, your cubic functions can also be having a graph that looks like this, a cubic function. If you have a graph like this, what do you say? Is this decreasing or increasing at an interval?
No, it's all decrease. So all increasing.
It's all increasing. Okay, so it's all increasing. You start there by x1. If you go here, x2, it is now increasing. Even if you move closer, it is still going to be increasing. Okay, so there. So the thing here is, it's very easy to visually confirm a function if it is an increasing or decreasing function because you can see it. However, when you are doing your calculations, it's very difficult to produce a graph just to identify if it is an increasing function or decreasing function. Okay? Take, for example, remember the medicine inside a person's body, that test or that activity that we solved or that problem that we solved last time. You are now given a certain function. So, how are you going to determine if that function is now increasing or the amount of medicine in the body is increasing or the amount of the medicine inside the body is decreasing? Okay? So, there must be a shorter way or at least a more easier way to determine if we have an increasing function or decreasing function aside from graphing, okay? Graphing the function. Okay, the answer to that is determining your gradient, okay? Just look at this. A decreasing function has a gradient which is now a negative gradient. While an increasing function, even if you have a curve, you just need to get the gradient function of that tangent. And if it is now a positive, then you will now have an increasing function. You understand the logic behind it? I'll repeat. We can determine if it is now an increasing function or decreasing function by determining the gradient or the gradient function of that particular equation. If the gradient function is like that and you are given a positive gradient, then it's an increasing function. If the gradient over here going down there is now going down, meaning it is now going to have a negative gradient, then that means now that you have a decreasing function. There's no increase or decrease. It's neither increasing or decreasing. You get the idea? You get the idea or the reason behind it? So
Yes,
here,
teacher.
remember your tangent? That is now a negative gradient, so decreasing. Here is going to be a positive gradient, so that is now going to be increasing. And to be able to find the gradient function, what do we do again? We need to take
Tangent.
what are you going to do? Well, it's not a tangent. What we're going to do is to find the gradient function of the tangent. How do we get that?
Derivative.
The derivative. How many times? First, second, third, fourth? Hmm? To determine if a function is increasing or decreasing at an interval, we perform the first derivative, okay? the first, okay, first derivative test, wherein if we have here f prime of x is greater than 0 for all values, greater than 0 for all values of x at an interval, then the function is increasing at that interval. Okay, so that's the definition, or that's the purpose of this test. You take the first derivative, take note, first derivative aja. Take the first derivative of the function and then test it, find the values of x. If it is all positive in that interval, then it is now going to be it's increasing function. Okay, and conversely, if okay, if f of x is lesser than 0, take note, it's lesser, that there's no equal to 0. If f prime of x is lesser than 0 for all values of x at that interval, then the function is decreasing at that interval. Okay, it's going down at that interval. Okay, so as to determine if a certain function is increasing or decreasing without really graphing it. Okay, so let's test it out. If, for example, we have here y equal to, let's say that we have here y equal to 2x cubed plus 5x. Okay, y equal to 2x cubed plus 5x. Determine if this the function is increasing or decreasing in all values. Now, all values of x. It's not only an interval. Okay? So, we start, we just follow this. We use the first derivative test. So, from y equal to 2x cubed plus 5x, we get now your first derivative, y prime. What's your y prime? Anyone?
6x squared plus 5.
6x squared plus 5. So this function now is our this is the function, and that is what we are going to test. We test it with the values of x in this interval, but in this particular problem, all values of x, and see if we can either get greater than 0 or lesser than 0. So to test, we need to assign values in x. It's just a test. So we can test like when x has a negative value, x is equal to 0, and x is a positive value. So determine negative 3, or make it easier in our part, negative 10 0, and let's say positive 10. These are just random numbers, one to test in the negative side, one to test at 0, and one to test at the positive side. Okay, so evaluate when x is negative 10. What is the value of y prime? Is it positive or
Positive 605.
negative? Negative 10, y prime or the gradient is positive. Okay, it's greater than 0. Okay, y prime is 605, which is now y prime is greater than 0. Okay, next at 0, at x equal to 0, y prime is equal to what? 5, correct? And y prime is still greater than 0. Last, this one, at x is equal to 10, at x is equal to 10, y
Also
prime is
605.
605. And that means the y prime is greater than 0. Sorry, y prime is greater than 0. So that's our first investigation. If I will now ask you, will there be can I put a value here that can make this function negative or lesser than 0? Is there a value that I can place here that can make this function negative?
No.
No.
No. Okay. Even if I put any negative number here, because that's a square, negative value squared will always give you positive. So it will always return back as positive. So it is now safe to conclude that what type of function do we have? This function is increasing or decreasing in all values of n?
Increasing.
It is now an increasing function. See, we were able to determine if it is an increasing function or decreasing function without graphing it. Okay, using a simple first derivative test. Clear?
Clear.
If this one turns out as negative, lesser than 0, or y prime is lesser than 0 in any of this, then it is now going to be a decreasing function. Okay? Clear? So we will be
Sure.
having more examples on this. Yes, Javier, have any questions?
So even only one negative, it's all decreasing function.
No, 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 no. If all positive like this, it is now an increasing function. If all negative in your test, that means it is a decreasing function. But if you get mixed values, there are parts of the graph that gives you a positive result, and then there are parts of the graph that gives you a negative result. Then that means it is increasing or decreasing. So if let's say a parabola, the one that we have a while ago, remember we have the negative side, which is now covered by negative 10. It will give us an increasing result, right? At 0, here, it will give us a flat result, 0 result. This is now here from 0 or from negative, positive 10, it is now going to give us a negative result. So if you have mixed result, okay, is that one clear, Javier?
If we have a mixed result, sorry, what teacher? Kind of cut.
If you have a mixed result, it is either increasing or decreasing at an interval.
Okay, teacher, thank you.
Okay, is that clear to everyone?
Yes, it is.
Okay, so I think that's it for today. We will have more on this by next meeting. Goodbye, everyone.
Goodbye and thank you, teacher.